Chapter 1, Section 4 is rationalizing the denominator. And way before I was ever a math student, somebody came up with this crazy rule that you cannot have a square root on the bottom of a fraction. I don't know why, it was way before me. So to get rid of the square root on the bottom of this fraction, everybody agree we could just multiply by 1 and it's the same thing. But instead of writing it like that, we're going to write it as the square root of 3 over the square root of 3, which is just a really fancy 1. And when we do that, 1 times the square root of 3 is the square root of 3. On the bottom, square root of 3 times the square root of 3 is the square root of 9. This is a perfect square, so you end up with the square root of 3 over 3. This is what we started with. This is what we ended with. Letter B, we're going to multiply it by the square root of 7 over the square root of 7. 1 times the square root of 7 is the square root of 7. 7 times 7 is 49. And this is a perfect square, so that comes outside of the square root. Again, take a look at what we started with, take a look at what we ended with, and look and see how they're related. Take a look at what we started with, take a look at what we ended with. Letter C, multiplying by our fancy 1, we will end up with 2 square root of 7 over the square root of 49. This is a perfect square. Square root of 49 is 7. Take a look at what you started with. Take a look at your final answer and see how they are related. And with some of these, you're going to notice a pattern. And some of you might be able to do letter D all on your own right now. If you can't, multiply the top and the bottom by the square root of 5. So you have 3 square root of 5 over the square root of 25. This is always going to be a perfect square, and you end up with 3 square root of 5 over 5. Now notice right here, we started with 2 over the square root of 7. Both of those were on top, 2 square root of 7. And the number on the bottom is the same as we started with, only we don't have the square root sign. Here we started with 3 over the square root of 5. Both of those moved to the top, and then we had square root of 5 that comes out of the square root sign. So looking at that pattern, letter E, these two things both move to the top. 4 square root of 6 over 6. This one we have to take one more step. 4 over 6 reduces to 2/3. So you have 2 square root of 6 over 3. Letter F, these two things move to the top. 2 square root of 11. And then the 11 stays on the bottom. Letter G, 4 square root of 10 over 10. 4 over 10 can be reduced to 2/5. So you have 2 square root of 10 over 5. Letter H, 6 square root of 2. Those both move to the top over 2. 6 over 2 reduces to 3 square root of 2. At the top of the next page, these two things move to the top, 2 square root of 5. And then on the bottom, you just have a 5. Letter J, 3 square root of 7 over 7. Letter K, 6 square root of 3, those both move to the top, over 3. This one can be reduced again. 6 divided by 3 is 2, square root of 3. Letter L becomes 10 square root of 5 over 5. 10 over 5 reduces to 2 square root of 5. Letter M starts out as 2 over the square root of 3. Both of those move to the top. And then on the bottom it comes out of the square root sign. Letter N, 8 square root of 2 over 2. 8 over 2 reduces to 4 square root of 2. O becomes 6 square root of 10 over 10. And 6 over 10 can be reduced to 3 square root of 10 over 5. Letter P, 4 square root of 8 over 8. 4 over 8 reduces to 1/2. So you end up with the square root of 8 over 2. However, there's one more issue with this one. That square root of 8, that 8 is not a perfect square yet, or there's a perfect square hiding in there. You can break that up into the 4 times 2, and then you can break that up into a 2 times 2 times 2. So that 8 is actually 2 times 2 times 2. Those are all underneath the square root sign, over 2. These two things can come out front, since those are a pair, and you have 2 square root of 2 over 2. And then these cancel, and all you're left with is the square root of 2.